I mean, we actually avoid the ThoughtWorks. We avoid the term best practices because it's a very loaded term. I mean, why would you ever do anything other than a best practice? I'm going to use some not quite so good practices. This one, and the terminology we like to use for what we do is sensible defaults.
Hey there, welcome to Book Overflow. This is the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, with my co-host, Nathan Toops. How are you doing, Nathan?
Doing great. Hey, everybody.
Well, this is another special episode of Book Overflow for you. We were fortunate enough to interview Martin Fowler, author of Refactoring, on the podcast. We've covered Refactoring in one of our earlier episodes. Fantastic interview. We're really excited for what we have in store for you. Nathan, do you want to give him a sneak peek of what's to come in this episode?
Yeah, he's a really good interviewer because he asked us a bunch of questions too, and it was pretty fun. It was fun to have to justify or dive into how we came to where we are in the industry, and it was very conversational and a lot of fun. And again, classic experience where we get to ask deeper questions of the authors of these really great books that we've read. I don't know. It's always so impressive to hear the clarity of thought and the expansion on ideas that are, in their minds. So yeah, Martin's pretty cool.
Absolutely. We talk about how we got the idea to write Refactoring, kind of the etymology of the term refactoring. We talk about the legacy of the book, how we've implemented it in our day-to-day lives. Fascinating guy, fascinating interview. So fortunate to have him on the podcast. We hope you stick around for the whole thing. So please enjoy this interview as Martin Fowler reflects on his book, Refactoring. Well, Martin, thank you so much for joining us today. It's great to have you here.
Hey, it's fun to be on the podcast. I'm glad to know I'm not entirely a fossil. People still want to talk to me.
Well, I've had a lot of great response because I'm on Reddit a lot. This is a secret to anyone who listens to the podcast. I pay for an app that gives me notifications whenever anyone mentions on the programming subreddits the keywords like book or podcast or whatever, and so I try to get in to respond quick. And so usually people are asking well, what's a good book to read? And I almost always recommend Refactoring. And that is, out of all the books I recommend, usually the one I've seen that gets the best reaction. People say, oh gosh, I read Refactoring years ago and, loved it. So it's got quite a bit, a following. And so we don't think it's a fossil at all. We think it's just as applicable today as it was when it was written.
Well, it may not be a fossil. On the other hand.
Well, why don't you talk to us a bit? We read the second edition Refactoring, but when was the first edition written? Was it like 1999?
In the late 90s was when I wrote
in the late 90s.
The Refactoring book, first edition.
So maybe you can give us kind of a two-part answer to this. We'd love to know why you were motivated to write it in 1999, maybe describe the computer science industry back then, but then also let us know why you felt the need to do a second edition more recently.
Okay. So let us zoom ourselves back to the mid-90s, which is when Refactoring really came up. So, I mean, at that time, the software industry, things were very different. I mean, obviously, the internet was barely a thing back in the mid-90s. But more importantly, the software industry was in a state where people were looking at the way software was being written. It was all very chaotic. It was not very well organized. And they're saying, well, we really have to get better at this stuff. And the vision of getting better was we had to basically be inspired by real engineering and do things like create detailed design documents in great detail before we do anything, serious like programming. There was this sense of when you started to write code, you were like pouring concrete. You could never change that. It was so hard to change the code, but you just didn't want to, you want to make sure you had to get everything right before you did that. And this is a problem. It's a problem particularly because if you want to know if you're going to start a 2 or 3 year program of work, you got to figure out everything the system has to do before you can start writing code because you've got to get everything straight before you pour the concrete, right? That's what real engineers do. But the problem is it was very hard. You could never figure that out. I always used to joke that, I'd go up to a development team and they would say that they were concerned about the fact that they got changing requirements. And this always surprised me, because I was surprised anybody would find changing requirements to be an unexpected thing, because it happened all the time. But if you're changing your requirements, how do you deal with this big slab of concrete, right? And that was at the heart of the problem. We knew we needed to go to a more iterative approach to writing software, where we could actually build a bit, get it into production, see what happened, and cycle it. Maybe doing something like that every 6 months, perhaps. Maybe not. No, that's a bit fast, but. But how do we then change the code that we've already got? And there wasn't really a great answer to that. And part of the answer was object orientation and the use of objects, which was still very, very new at that point. I mean, C++ and Smalltalk were around. Java was kind of barely crawling out of its wherever, of James Gosling's head. But it's still early days. How do we deal with that? And I've got some inclinations about this. In particular, I'd had this amazing light bulb, mind blow experience in a conference when I was listening to Dave Thomas. And this is not Prag Dave of the Pragmatic Programmers fame. This is OTI or Badara Dave Thomas, who built OTI, Object Technology International. He was on stage and he said every class should be self-testing, should know how to test itself. And that really made me go, oh, wow, what do I do? And I went back to my project I was working on at the time, and I set it up so that every object in the system would test itself to know that it was working. And when I did that, it was an amazing change, because suddenly I could now change my existing code and know what I'd broken and fix it. And that was a step change, because now I was much more confident about changing my system. So I was beginning to see how we could start dealing with this big mass of concrete. Then I had the opportunity to be on the C3 project, Chrysler Comprehensive Compensation, with Kent Beck. And this was a project that really launched a lot of the kinds of programming styles that you've been talking about, we've been talking about. And early on that project, I asked him to do some code review of some of my Smalltalk code. And I have this vivid memory of being in a hotel room, probably a courtyard, somewhere in the suburban Detroit, and him going through doing a code review for me. But this wasn't a code review where he sat there and said, this is what you should change. He would actually sit there with me in the on front of the laptop and say, well, maybe this would be different if it did this. And he would change it right there and then. Tiny little change, tiny little change, tiny little change. And that was another mind blow. The realization that by making a sequence of tiny little changes, you could actually make a very big change much more safely, because you weren't breaking things. And of course, you had the tests there to double check on you. And that was the approach he applied to this project as a whole. And you had half a dozen people, a dozen programmers doing it. And with that, together with continuous integration to make sure we're all in sync with each other, it was a shocking change. The concrete was now completely broken up. We could say, hey, the software looks like this. We make a mistake in the design, we just change it. And that means you no longer have to think about every possible thing that you've got to do in the system, because you're now confident you can change things. And it means it really just completely alters your design mentality. It alters what you think of as software design. So I was very much a design background guy. You know, I wrote one of my first books on the UML. I was very much steeped in the object-oriented design world. I realized that my whole thinking about what design meant altered. And so I wanted to tell everybody about this. I wanted to say, hey, you've got to know about this stuff. And they would say, so where do I go to for information? And I go, well, there's nothing there. And I talked to Kent, and he was busily writing the white book at the time. So he wasn't prepared to write it. So I decided, well, I've just got to damn well write this book myself. And that was what led to the refactoring book. And the main thing I did was, as I did refactorings, I would make notes about how I did them. And then when I went back and did that same refactoring again, I'd look at my notes. How did I do this? How did I make this change? And then I gradually refined the notes. And that was the backbone of the book, was those notes. So that was the original book.
Reading this book was a big eye-opener for me. I don't know. I think I thought for a while, like, if any system is complex, that means it's scary to change. And so a system being scary to change means it's complex. And if we're doing complex things, that must mean we're being good engineers, right? And yeah, it was this, and we also read Working Effectively with Legacy Code, which I believe we got as a recommendation from this book.
Right.
And Nathan pointed out in the podcast that there's actually a circular dependency, because Working Effectively with Legacy Code recommends refactoring.
Yep.
But where it really clicked to me that, like, you don't need to be scared about changing your code, and that there are solid, effective strategies that you can employ to gain that control over the code base.
Well, you don't need to be scared about changing your code if you've set up the preconditions.
Absolutely.
Right.
Absolutely.
And that's part of the thing that's always hard to express to people. Refactor, the kind of stuff I talk about is an insane strategy if you don't have tests, if you've not got a decent integration system going on, if you don't value writing clear code all the time. But once you move into that mode, and you'll adopt that mindset, that's when things change. And this is where I've noticed two words that have not come out of your podcast in all the episodes I've listened to, even though you're talking about it all the time. You've never used the term extreme programming.
It's true. We haven't.
Because that's what this is all about fundamentally. And that's what Kent was doing on that Chrysler project. That was the birth project of extreme programming. But extreme programming is all about combining all these things: continuous integration, self-testing code, TDD, refactoring, Yagni. All of this stuff comes together and combines to make the engine that allows you to grow. And refactoring is at the centerpiece of this. It can't be done without the other supporting practices, but when it's done with them, it enables a whole different mindset.
Well, and I think it's a great way to illustrate the value of unit testing. I know that unit testing, especially amongst newer developers, I remember that was one of the first questions I asked in my internship to the senior engineers. I said, why do I need to unit test? Don't I know it works because I click the buttons and it does what it says it's going to do? And even those senior engineers, I don't think had thought about it in the way you thought, because I think there is some truth to the idea of unit testing. That's like, if you view it as ultimately like, this is the thing we just have to run before we send it off to the build to kind of do a bit of a sanity check. Like, unit testing, I think, can seem like a lot of effort expended for little value returned. But if you instead view unit testing as, this is the harness I can put around my code that can make me confident in refactoring it, to me, that was a real eye opener. And all of a sudden, the value I'm getting out of unit and tests increased tenfold.
It's my automatic bug detection system, right?
Absolutely.
I press a button and say, have I got any bugs? I mean, it's not going to get all of them, but it gets all the ones I know about and can conceive of, which is still quite a large amount of bugs, because I'm very imaginative at coming up with bugs when I program. Trust me on this. And that's a great thing. So did either of you do refactoring at all before reading the book?
Not in the way you recommended. Like, obviously I've seen code and thought, okay, this code could be cleaned up and it could look a little better. And then you try to clean it up. But it was always the code I would try to clean up. It was always kind of like in proportion to how vital it was. Like, if this was a centerpiece of the application and critical to the business logic, I would not touch it, because what's the point in making it cleaner if it's going to break everything, right? But if it was anything kind of around the margins, and if I could kind of test it fairly easily after my logic, I would, I'm a Boy Scout, right? So I was always taught, like, with campsites, like, leave them better than you found it. And I try to have that same thought with the code base, but I think I also kind of thought, like, well, you're definitely not leaving the code base better than you found it if you break everything. And yeah, these critical pieces are really subject to being broken. So again, there was just this thought of, like, better safe than sorry here. So I was familiar with the concept of refactoring, but I think I was very scared to apply it to anything business critical.
And Nathan, how was you on that?
So where I've used it extensively actually is on personal open source projects. I think partially because you could see my code. And so I thought, just out of respect, I should have high test coverage. And sometimes when I was building out systems, of course, no one's using it but me, typically, at least early on. It was absolutely essential for if I had ideas of how I wanted to change, function signatures, especially stuff that was internal. It was much more like having all those tests in place made it so that I could very confidently swap things out and know that I didn't have side effects. And so um, most of my code has been around modern languages that have good testing infrastructure. Like I've mentioned this before, but Go is my favorite programming language, and testing is a first class citizen. It also compiles really quickly, so it's really like ergonomically like very nice to throw into a CI/CD system, and you get feedback really quickly. And I was able to, in some cases, like do fundamental redesigns to the inner workings of stuff without changing external function signatures, right? Like another important thing with open source is that once you've kind of created a design, this is where refactoring is important, is that you're not changing the behavior of the application externally, right?
Yeah.
Otherwise, you've kind of taken a step out of refactoring at that point. But it was actually so it's mostly been personal projects, or it's been so I work in platform engineering a good bit, and now I actually just took a job in software architecture. It's like my official title, which is really a fun thing. And so I'll be working in this world of like fitness functions, and using it as a steering mechanism for how the organization can make decisions internally. And so, taking those personal experiences that I've had with like open source toys that I've been building, I didn't have a vocabulary for it until I read Refactoring, though. It was kind of interesting. It was like a lot of like these all felt correct. I was from the DevOps world, so we did a lot of test automation and things, and I knew that they were important. But I think maybe I adopted some behaviors without knowing exactly why. And this is what I appreciated once I read Refactoring. I was like, this is why. Like this is the philosophy underneath the behavior that I was participating in.
Yeah, that was the next question: is did reading the book change your relationship to refactoring and how you used it in your general workflow?
It helped me in, I think, in the similar conversation with like with Carter, which is that I engage a lot with software engineers, and it's surprising in the various organizations I've been in with how many software engineers either have like an incomplete understanding of why the fitness functions and the test coverage is the way that they are. And it's really easy within a company to get pressure from leadership or pressure from a product manager to skirt around process. And I think for me, refactoring was a really good way of saying, like, it's not just me telling you I did this on like 3 other projects and this is a cool idea. It's like, oh, I had this like authority to say, this is a pattern. This is actually where success comes from. We shouldn't skirt around this. Otherwise, we're going to build up tech debt so quickly that we're not going to know what bugs are getting introduced in the future, right? So
I will, and it did directly influence how I do it now. And I think I even shared on the podcast a story where I was working with an Apache Beam pipeline, and we had one of those things where it was like one of those kind of like what's the word for it? I think it's like exclusive if, or some kind of like anti-pattern, where basically like it was one of those things where it was like, if customer ID is equal to this, then do this. Like one of those basic like use cases built in. And I saw it and I'm like, ugh, like that's not great. Like it'd be better if we could move this to some sort of like config value, approach. So we don't just litter the code base with ifs. But I looked at it and I was like, well, this is a nice to have, but I don't want to modify it because again, what if I break the pipeline just to like make this nice to have? And then I remembered, like, wait a minute, I can be confident in this. And I wrote up a test to validate that it would, work properly. Swapped it all around, ran the test, validate, and then everything was green, and and was off to the races. So that was an example just recently where, I mean, that was a direct result of having read refactoring. And I think before I would have just said, well, it'd be nice to change this, but why risk it?
Yeah, because it's the critical code at the center of the business, which is the most important stuff to refactor. Absolutely.
I mean, something you talked about with the idea of software estimation, right? And how, because I think that's kind of critical to the idea of refactoring, is the idea that the requirements keep changing. and we need to be able to build our code in such a way that can conform with these changing requirements. It's interesting. My wife is actually pursuing a degree in computer science right now. So she's just starting programming. And as she's been doing it, she says it's surprising because the things I thought wouldn't take a long time are taking a long time, when she's working like a personal project. But then this thing I thought would be really hard is really easy. And I kind of told her, I'm like, we've been trying to solve that problem for 50 years to be able to accurately measure and scope how long it takes to build a software project. What is it about the field of software engineering, do you think? Because like you mentioned, it's different from like hard engineering, that makes it so difficult to understand how complex or how long something's going to take.
Well, it's because it's so deeply ingrained in human processes that it's very hard to get those out and be explicit about them, particularly when you don't know how the presence of computers is going to change those processes, because there's a feedback loop going on. Once you've got the computer, then suddenly you realize, oh, this thing that was hard before now becomes easy, and I have to reconfigure my way of working. And you've got this constant movement in that sense that's going on. And people will always be surprised by what happens once you get the software in place. I mean, I remember there was a study done by a very serious group within, I think it was Microsoft, that did a lot of careful analysis of features or whatever. And they figured out that even with that, a third of the things that they thought were necessary weren't used. And that doesn't surprise me at all. I remember hearing one of our projects where they did an initial plan. They went, say it was a year-long project. I don't remember the exact number. They went a couple of months in, and they realized they were not going to be able to do all the things that were on the plan. They would only be able to do about 2/3 of them. And there was much wailing and gnashing of teeth and all the rest of it. Client was unhappy. But of course, they found out a couple of months in, not a couple of months before they were supposed to deliver, which is the way it usually goes. But anyway, they finally said, okay, we'll deal with the 2/3 that we can do. And they went through and they delivered. And then a few months after the first delivery where they had this, they said, hang on, that was 1/3 of stuff that we thought we needed to build. We haven't missed it. We didn't need it. We've saved the money to build it that we otherwise would have built had we not gone for an early delivery. And again, that's another reminder. It's a constant case of we can't imagine what the software is we really need to use until we start using a bit of it, and you have to do this sense response process. And there are other processes that do that. There are plenty of things in life where you do have to do this sense response, where the unknowns are just too much out there, and you just have to do a little bit, see what happens, and come back again. The example I use is go into a hotel shower. I'll guarantee you cannot go up to the dial, turn it, and know that's going to be the setting and get in there and have a good shower, right? You would be silly to do that, right? But so what you do, you sense and respond. And that's the way you deal with unknowns. And that's the way we have to work with software. And the critical thing is to do that without the technical practices is very, very hard. And that's what extreme programming brought to the table, a set of technical practices that would make this stuff work. And that's the genius underlying that approach. And refactoring is one of those, an essential one of that set.
I was on a team in a fintech company that I've talked about a few times. It was like the highest functioning team. We had a phenomenal engineering manager. It was all senior level talent. And we were just able to fire on all cylinders. It was the first time I'd experienced it. It's actually the only time I've experienced it in its totality of the time I was there. And one of our principal software engineers was a huge advocate for extreme programming. And you're right, I have not talked about this on the podcast at all. And it made such a difference because our approach to problem solving was really built in this sort of provability and these hypotheses and making small experiments and being able to turn around. And it was the first time I'd ever seen like a real, like, 10x programmer, where he was so comfortable in the code base that we could iterate on these ideas very quickly. And yeah, it was fascinating. I know I learned a lot from that experience. I felt all of us during our time there just became a really tight knit group that were able to trust each other. And a lot of us worked independently. We typically worked in pairs, off independently. But we had lots of things like these social contracts where we would make sure that, we knew that if we independently deployed services, that these services would not break, because that was one of the contracts that we had. But of course, we also had fitness functions and really nice testing to like verify that these things were in place. And yeah, it's interesting though that this has been it's been like maybe 2 or 3 jobs since then, and I haven't been able to rekindle that yet, actually. Which is also an interesting thing to think about, I guess.
It is hard because it is, and this is the biggest challenge I think for the agile world generally, is that the thing that is the kryptonite for agile software is when you can't trust the people you're working with.
Yeah.
Trust is such a central thing, and it has a lot, of course, to do with broader social relationships. If you don't have trust, it introduces a lot of friction in the transactions, because everything you do, you have to be based around the fact, I can't trust what people are telling me. I can't trust that people are going to do things as they say. It slows everything down. Imagine how we have food safety standards, right? Imagine what the world would be like if we didn't have those. Right, and you had to think, can I trust buying my milk from this shop as opposed to this shop, because I don't know what they put in that milk over there. And in fact, this was the case. I read a lovely book a while ago that talked about the origins of food safety in America in the late 1800s, because it was quite common in those days that, when the milk started to go off, they put formaldehyde in it so that you couldn't smell it was going off. And that was normal, right?
Yeah.
I mean, I'm seeing Nathan's reaction. That was the kind of thing that was expected. And what happened, of course, is over time, it's still got its problems, food safety in America. Don't get me started on that. But it's a hell of a lot better than, formaldehyde in the milk. And those kinds of things occur. Once you build up trust, you can remove a lot of friction from the process. And that has happened. That's actually part of the challenge of our broader civilization, is we're building up ways in which we can trust people. We can go to a shop and pay them money, and they will actually believe that that money is real, right? They don't have to weigh our coins to make sure that they're the right weight and try and figure out if they've actually not been debased with the gold or anything. They can just trust us. And similarly, we can have a degree of trust with them. And the same thing works in software projects. If you can trust the people around you to the right level of degree, then you can do a whole lot of things differently. And that's at the heart of many of the assumptions, I think, in extreme programming, is that if you had a team like that, how could we work? And how fast and fluid could we be under those kinds of circumstances? And that then it says important things about the kind of people you work with. At ThoughtWorks, one of the things that drew me to the company back 20 years ago when I joined was they really paid attention to making sure that the people they hired were people they could trust. And integrity was one of the core elements of the organization. And that means all sorts of things that otherwise you have to put as corporate controls, you don't actually have to have, because you can basically say, I do trust that most of the people are doing the right thing most of the time. Harder as you get bigger to do that, of course, but trust is an important part of it, and that's an important part, I think, of what makes extreme programming work.
How do you build that kind of trust?
Well, that's then the tricky thing, right? And that's why it's the kryptonite, because when you can't get that, and it doesn't take much to undermine it. I mean, when I think of, an interesting example, if I think back to that C3 project, a large part of what built the trust was having a group of people that ended up self-selecting. The previous iteration of the project had got into really, really a lot of trouble. The dodgy people basically bailed out because they saw it was bad, and the people that were left were the people who did have a good degree of trust for each other. But it's also a part of building an environment that encourages it. One of our chief lawyer at our company makes the point that if you can create an environment where you feel safe to trust other people, then it actually becomes a positive reinforcing thing. And part of that as well is transparency. Hey, everything we write in our code base is visible to everybody. I expect everybody to see all the code. I expect everybody to edit all the code. We don't have code ownership here. And then that encourages a degree of transparency. Tests, of course. I'm trusting that I'm going to have tests in the system. That helps build up trust. So those things can help. But I mean, then we're talking much more sociological area that I'm not an expert in, right, in terms of building trust more widely. But I can certainly say that where I've seen projects with difficulties, at the heart of it often is the fact that there is that lack of trust occurring. So how do you see refactoring amongst your colleagues and in the bits of the industry that you see? Do you see people doing it? Do they do it well? Do they not do it at all? What is people's relationship with it?
I genuinely think that it's funny because, well, and so maybe I'll ask you a question before I answer your question. As far as you know, are you the person who invented the term refactoring? No. Okay.
Absolutely not.
Okay, gotcha. So your book is just the roughly authoritative source on it, but you had heard of the term refactoring
before. The term had been around for quite a few years beforehand. There's a post on my website called Etymology of Refactoring where I wrote down what I had done, and I'm actually going to quickly look for it because I don't remember. But it basically came out of Ralph Johnson's group at University of Urbana-Illinois, University of Illinois at Urbana-Champaign. His group was very active in Smalltalk and in a lot of object-oriented frameworks, patterns. Ralph Johnson was one of the authors of the Gang of Four book. And that was very much where it came out of. In fact, actually, now I'm looking at that post and it's reminding me. So some people think it comes from the notion of factoring in mathematics, where you break down things into factors. And by refactoring, you're kind of changing the factors. But another answer said that they were talking about software factories, which was a thing back in those days, and said, well, we shouldn't have software factories, we should have software refactories, because we're constantly going through this constant work and change. Yeah, so that came very much out of that group and the Smalltalk community that led to the term.
Well, so to answer your question, the term refactoring, I think if I said that to any programmer I've ever worked with, like I'm going to refactor my code, everyone knows what that means. And everyone knows that means roughly to make your code better or more maintainable or manageable. But I mean, again, after reading this book, like I've been fortunate to work at some well-known places. I've worked at some big tech companies, a lot of places you've heard of. And at those places, I've been really fortunate to work with really, really good engineers. And so I think that's what surprised me when reading this book, because despite having worked with lots and lots of great engineers over the course of my career, I have never heard someone kind of make that connection. Again, like the importance of testing when refactoring your code, right? Like I have never, to me, it was a real light bulb moment. And so like, obviously I've heard people say like, I'm going to refactor this code, but the refactoring is always referred to changing the code to make it better. It's never been a holistic process that either means relying on the tests strongly while making these changes, or perhaps writing new tests to validate these changes. And I'm sure that maybe some of the more like senior principal engineers, maybe they just understood that implicitly. Certainly not the more run-of-the-mill engineers. But it's one of those things where it's like, even if maybe some of the more senior folks understood it implicitly, this knowledge was not being passed down and communicated to the more run-of-the-mill engineers that you cannot refactor safely without tests. And for me, it took until reading the book to make that connection.
This is an interesting area where our experiences are pretty different. I've had a lot more experience in early stage startups, where we ended up having, we either had some like what they call, I guess, cowboy code or founders code that we were transitioning into something that we needed to rely on as a team. So, maybe this was 1 or 2 people writing code and getting prototypes out quickly and raising money, and then turning this into something that we actually had to rely on. And those were ripe with refactoring opportunities. Again, going back to that fintech company, we had a fundamental initiative based on introducing inversion of control, which made it a lot easier for our DevOps deployment processes, because we were able to do a bunch of really nice dependency injection patterns so that the code never had to know, are we using some advanced and sophisticated logging system, or is it just going to console? Do we have distributed tracing in place, or is it a no-op, right? Like these kind of things, you didn't have to think about it in your code. And so we didn't change the business logic in a lot of cases, right? We changed the structure of how things interacted with one another. And again, a lot of times it was opportunities where maybe we were writing tests for the first time, or we realized that they were woefully inadequate and that we needed to test a hypothesis of maybe how this new dependency injection pattern would work. We actually needed to reimagine how we even tested stuff. Sometimes I think I'm just trying to think of things out loud of, whether it's a fake or a mock or other things with database abstractions is a great example, where a lot of times early on, you might just spin up a database or have it access to certain things, which is, disastrous when you actually want decoupled testing patterns. And sometimes those functions weren't written in a way, right? It assumed that there's some global database client with a pool or something. And, it's very hard to reason about. And, and so these refactorings that would come in where, sure, maybe we're changing how a database client was injected into a class. It didn't change any of the behavior of what the trading algorithm did or these other things, other than we might have actually found that what accidentally was correct behavior was actually because of some weird thing that existed in the code that nobody had reasoned about until you wrote a test and found the edge case and then realized this was an accident, right? And those are the scariest ones, because you end up getting these weird connaissance of timing or other weird things that would happen in your coupling patterns that would be in place. And so maybe I got to see a little more, I'll call it exciting. I'll use this euphemism for exciting, which is we had to transition from maybe an immature environment to a more mature one. And so I got to see the product of this, again, without the vocabulary. I didn't know why all of this was cool, other than I was like, oh, well, I get paged less, or these other nice things that would come in.
We've really enjoyed that about the podcast. I think there's a fair amount of virtuous cargo culting going on in the industry, I guess is how I'd put it, where it's good to write tests. And people, if you ask and say, is it good to write unit tests? Say, oh, of course. You can't ship without unit tests. And having unit tests is better than not having unit tests. But then I think if you ask people why do we write the unit tests? And I kind of said at the beginning, I think most people would say, well, it's a nice little check that everything's working before we deploy, right? But then again, not realizing that, no, it's also a way to be able to refactor your code. I think it's interesting because I think a lot of people will kind of hide behind oh, this is a best practice. And I think what's funny about that is a lot of times when people do say this is a best practice, they're usually not incorrect. Logging is a good best practice, right? But then not necessarily knowing, well, what's the actual reason? What's the philosophy behind that? That was actually one thing I discovered when reading Working Effectively with Legacy Code, is I kind of looked through some code base. I'm why is everything abstracted behind an interface? Just give me the class, right? And then reading about, kind of that inversion of control, and then the ability to swap these things out for mocks and stubs in testing environments, right? And so I think there are, and I've also run into some developers who kind of just by nature, especially a Java environment, everything is put behind an interface because they've seen that for a long time. And that's just what good Java programming looks like. But I don't think could tell you the reasons behind why they do that. So we've really enjoyed reading all these books for the podcast and just realizing, it's kind of great because it's either we come and realize we're doing things we shouldn't be doing and find out why we're not doing them. And even if we read things that we are doing, we often find out the more holistic reason behind why you should do those things. So it's been fascinating reading all these books and kind of coming to those conclusions.
Yeah, that makes sense. I mean, there's a common pattern you see in people talk about learning, where early on you kind of just follow rules relatively straightforward way, and then over time you start asking why, and then you start sort of doing more things. It's been formulated various different ways. I rather like the way that Clark Terry, the jazz trumpeter, put it. Said, imitate, assimilate, innovate. So early on, you've just got to imitate what people do, and then you assimilate from different places and begin to question the why. And then once you've been doing that for a while, you can then do the innovative stuff. And so that's a natural direction to go. But I mean, it also, I mean, we actually avoid the ThoughtWorks. We avoid the term best practices because it's a very loaded term. I mean, why would you ever do anything other than a best practice? I'm going to use some not quite so good practices, this one. And the terminology we like to use for what we do is sensible defaults.
Interesting.
So we have a bunch of things that for us are the sensible defaults. But of course that carries the notion of, if your context is different, then maybe the default doesn't work here. And you've got to adjust based on that. And that tends to be, and I think that's a good way of thinking about how to use these kinds of things. Because it's good, I think, to say, well, if I'm not sure, I'll go with the expected way of going things, because there's so many decisions I've got to make anyway. I might as well just not have to make that decision initially. But you always have to understand the why and begin to question whether the context is important. That was always an important part of patterns thinking, of course, is that the idea of a pattern was only an appropriate solution given a particular context. So you had to understand the context in order to decide whether it was appropriate.
I can't remember where I read it. Was it in this book? It might have just been a Twitter post for all I know. But it was, I think it was a discussion of, is there anything you should always do, no matter what programming project it is? Because kind of like you're talking about, like sensible defaults versus a best practice. And the consensus opinion was version control. They said that is the one thing you should have in every project.
That was what was in my head as you were saying.
Yeah.
I was thinking, maybe version control is the one.
Yeah.
My thought was
So-
that you should breathe. But I think version control is a close second.
Honestly, yeah. But I really like that framing of sensible defaults, because I get what people are getting at with best practices, where there's this idea of like, listen, let's not reinvent the wheel here. Lots of people have been in this industry for a long time, and it would be silly to throw out the accumulated wisdom of all of their mistakes in favor of, some bold new approach. But I like that framing of sensible defaults, which is like, this is a good starting place. Let's assume that this is a fine path to take. But should we be able to justify a different approach, there's no reason we can't do that. Because like you say, a best practice, that you can't beat a best practice.
Right. Yeah, and that's why I like that framing very much.
Well, Kristen, here on the Book Overflow podcast, there is a best practice. It is version control. And you are allowed to.
Yeah, it's very hard to see where you wouldn't want to use version control for pretty much anything these days. I mean, there was a time when setting up a centralized server and all the rest of it was actually a fair bit of work. But now it's just go get in it on your directory and you're off to the races, right? So it's really, really quite trivial. And I version pretty much everything. I mean, I don't version my photo library, I guess, because you can't diff photos very easily these days at the moment. But everything I do that involves text, which is most things that I do, because I'm addicted to using text formats for everything I possibly can, it goes straight into Git. I can't imagine life without it.
What's your thought on the legacy of your book? It's been around a while. I mean, refactoring it, and like I said, when I mention it on Reddit, it gets a very strong reaction, a very strong positive reaction. Well, what's your take on the legacy of refactoring?
That's a hard question. That's actually kind of what I was probing when I asked you, how do you see people using refactoring around you in the industry? Because it's rather sad to see that people think of refactoring without tests. I was reading a post from a colleague of mine who talked about how he was watched some video on refactoring, And the guy doing the video, it was a 1 hour video. He broke the test suite in the first 5 minutes and never got it working for the whole rest of the video. And you can imagine my reaction to seeing something like that. How on earth can you call that refactoring? So there's a sense of disappointment that it's not, that people have not experienced the circumstances, that don't really know how best to use it. And I mean, having seen situations where, the extreme programming gears are all humming and going really well, it's really frustrating to think that there's a hell of a lot of programmers out there who have never had that experience. But on the other hand, what best can you do? I mean, I hope I wrote as clear a description as I could in the book. The fact that there haven't been really any competitive books that have tried to replace it perhaps tells me that I did a reasonable job. I did the second. I didn't answer the question earlier on about the second edition. I did the second edition because I felt it was showing its age. The first edition, it was still valid, but it was showing its age, and doing the rewrite would help give it a bit more legs. I made it a bit less heavily object-oriented than the first time round, because the first edition was done in Java, which is an aggressively object-oriented language. And by the time I was writing the first book, Java was the future, the one and only language for the rest of time. I mean, you smile. That was very much the attitude. This is the final language that a lot of people had with Java. And so I switched to a language that wasn't as sort of determinedly objects only, to bring out some of the non-object things that you can do. But I feel good to that sense, that I feel it's still a solid piece of work. But you always look around and feel I wish more people were able to see what programming could really be like when you're on that kind of team. And of course, I then make it harder for myself because I live in this ThoughtWorks bubble where most of the people I talk to are like-minded folks, and so I get a perhaps a more optimistic sense of where the industry is than is warranted.
I mean, I think it's about as close out of all the books we've read on the podcast where I would recommend it as almost mandatory reading to any programmer. And we don't mean that as a slight to some other books. Like we loved Working Effectively with Legacy Code, but there's a truth that, like, well, if your code base is in a solid shape, maybe this isn't, the most effective read for you. We read Slow Productivity by Cal Newport, and it's like, well, if you're a junior engineer and you don't have as much control over your free time, maybe this book wouldn't resonate as much. I mean, I can't think of a single engineer I wouldn't recommend Refactoring to. I guess someone who's already read it multiple times is kind of the only person I wouldn't. So I think it is, out of all the books we have covered, it is one of, if not the most evergreen, broadly applicable books, which I think is very impressive.
So actually, that leads to a slightly broader question. So to what do you see of the role of books in educating developers compared to other resources, like things on the web or video or stuff of that kind?
It's a good question. Nathan, you want to give your take on it first?
Yeah. So my immediate thought is some ideas, the shortest way they can be presented is in the form of a book, which I think is why maybe the author chose to write the book, is that you need to spend some time kicking the tires and thinking about the idea in the way that it's presented. And I think the books that have stuck around, actually, Ryan Holiday writes about this. He's like, if I could have just made this a blog post, I would have. But, he ends up writing a whole book on Stoicism or something. And it's because you have to kind of hear the idea unfold. And you have to kind of get through all of the phases of his thinking. And I think some books need to take the time. And again, I think where Refactoring is really interesting is that, there's this premise that's sort of laid up at the beginning of like why you need all of these things. And then there's this like incredible reference section of tactics of, hey, you have this pattern. Here's a way that you can approach it. Here's how it helps with this and that. And here's some examples. And here's the motivation for why, the structure of that's really nice. And it helped me a lot. But if I hadn't read the first half of that book or the first 2/3 or whatever of that book, I don't think I would have appreciated why we're diving into motivation and diving these other things where, Sure. Sometimes I'm like, oh, how do I get Datadog hooked into Next.js? Well, a blog post is probably fine for that. I can just like figure out what the config needs to be and, make sure it's doing it the right way with SSL or whatever. That's my thought on books.
I can give a broader answer and then a more kind of software engineering focused answer, which is I think we live in a world dominated by short form content, right? Things like the rise of like TikTok and YouTube Shorts in some ways concern me just because it's rapid information. I am on Twitter and I like Twitter for checking in and like keeping up with, new ideas that may be coming out or the news. I try to follow accounts that I tend to trust. And for 5 minutes, it's great. If I scroll Twitter for an hour, I feel like my brain is melting out of my ears, right? My wife and I talk about, we have 4 sons and they like video games. And we kind of talked about like, what's our philosophy on video games? And I played video games growing up, but when I was growing up, video games were like, they were something that could be completed. And I have a lot of fond memories of like finishing a game like Super Mario 64 or The Legend of Zelda Ocarina of Time, of bringing all my brothers in to say, I'm going to fight the boss, everyone come watch. And then you beat it and then the credits roll. And you can appreciate it as this complete work that a lot of people, it's a work of art, and I just think we increasingly live in kind of a world where content is so disposable. There's just an unending feed of short form content you can consume. And so for books in general, like the base of it is just, I know how I feel after reading a book for an hour versus scrolling Twitter for an hour. And I feel great after reading a book. I feel educated and uplifted. Twitter, I feel like garbage. And then books for software engineers in general, because it was something we had debated kind of when we were starting this podcast is, and as a tech dominant media or a discipline like ours, what is the purpose of a dead tree kind of book? But I've really found that as you engage and grapple with an idea over a week or 2 or 3, it's surprising how much you realize, even if you thought you understood this idea, you actually didn't, or you learn new things about that. And actually, I think refactoring is a great example, because if you said, Carter, do you believe in refactoring your code? I'd say, absolutely. Of course, we should refactor our code, right? And if you had asked me if I understood what refactoring meant before reading this book, I would have said, totally. Yeah, you change the code, you make it better. But it was only after spending a week really engaging with this book where I realized, oh, like I don't know as much about this as I should have. And there are just so many books we've read where even if there are ideas that if they were scroll by on my Twitter feed, I'd say, got it, I agree with that. But then after engaging with it for a long time, you either develop a more complete understanding of it or realize that maybe you were mistaken. We kind of started this podcast with the books almost as a bit of a gimmick, because we thought, hey, this will be a great way to supply a good steady feed of content for discussion. But as we've gone on, I've just really come to believe that it's it's almost like a shortcut to leveling up your career and your understanding is engaging with long form ideas written by talented authors in their books.
Yeah, it's interesting because my writing energies these days are not focused on doing another book. I put all of my focus on my website, martinfowler.com. And in fact, I put all of my focus on other people's articles. I do very little writing myself, mainly because I feel I've moved so far away from the day-to-day of software development that I wouldn't trust what I have to say. So it's much more important that I find the people who are still on doing the day-to-day and help them express what they know and they learn. All right? But I think also there is a ground that is a kind of a middle ground between the short form nightmare of Twitter and TikTok, and the sheer size of a book. I have read quite a lot of books that I've written and said, this did not need to be 300 pages. And I've worked with people with stuff on the website. An example article, there's one of the articles on my website is called On Pair Programming, written by Birgitta and Nina, 2 of my colleagues in Germany, which really give a solid picture of pair programming. Why is it a good idea? How to do it well, that kind of stuff. If you put that into a book format, it would be maybe 30 or 40 pages. So it's not big enough to be a book, but it is, I would argue, long-form content. It has that same depth, but it covers the ground in the right amount of level, and then says, okay, we've got this area covered. I wrote, around the same time, I wrote an article on branching patterns. I mean, how to deal with software branches and version control and all the rest of it. And it probably, I mean, somebody actually did say, oh, this is going to be your next book, is it, Martin? And I thought, well, you know, it's going to top out at, if it was a book, at about 50, 60, 70 pages. I don't want to pad it into 300. I mean, actually, I think it's doing a disservice to the reader, because I'm trimming it down saying this is the most important stuff for you. And you know, I even do that in books. I designed the refactoring book so that you could stop reading at pretty much any point and you'd got the most important stuff.
Right. And
it was partly triggered by something Alistair Cockburn said to me many, many years ago when he says, I never read beyond page 50 of any technical book. So it reminded me to say, make sure I get my most important stuff in early. And if the reader says I'm bugging out at this point, they'll actually gain a great deal from that. And it's part of how I design my books. But I think we can actually do that because with the book publishers, it's very hard to get them to think in smaller sizes. I was very lucky that one of my early, most successful books was UML Distilled. And it had to be small because we had to get it, we were in a hurry to get it out because we had a time pressure. And it sold really well, even though it was only 150 pages. And that actually made it easier for Kent to write the White Book, the first extreme programming book of around that size, because UML Distilled had been successful. So they thought, well, maybe a short book of 150 pages we can get away with. But I think a lot of topics we can tackle at 40 or 50 pages and still have something worthwhile. And it's actually something I'd be interested to see folks like you do, is to say, okay, are there some of these long form, where long form is 40 or 50 pages, and still have that timelessness? One of the things that people are often surprised about on martinfowler.com is 3/4 of the traffic to that site goes to articles that are 5 years or older.
Oh, wow. Which
is not usual, especially when you know that even on my site, I get a huge amount of traffic when an article is first published. And if you plot it on a log scale, it's still an exponential drop-off. So you still get that effect, and everybody has that effect. But most people's reaction to that is to say, well, we need more new articles and constantly give new short articles so that people can read them. What I try to do, and I think there's room for this, is to say, no, let's look at that size that is more the 30, 40, 50 page article that's going to be that still valid in 10 years' time, and put that out there.
Right.
And I think there's a lot of room for that kind of thing. And that's hard to do with books, but still needs to be done with words, I think. There's a special thing for reading and prose words that you can't get from video. Because with video, I always have to consume it at the speed of the speaker. With text, I go my own speed. I can skip over stuff. I can slow down and reread and reread again. I control the speed. And video, I don't. Or it's so hard to do that you just can't really do it.
Well, it's funny. I had actually, I'd only ever consumed your blog content before I read Refactoring. So I was like, oh, I read his blog all the time. Like this was really interesting. And it's also been, I think I've been wanting to read a lot of these books, but most of the content that I look up are, people I respect, certain industries that I respect. I have like a personal interest in cryptography. So there are several cryptographers who will write about stuff that's coming out or why you shouldn't do certain patterns, that I really enjoy sitting down and reading their longer form blog posts. And I do think that is a great medium, as well. There are some books though and I will say we actually have a whole bunch of books we avoid. So, if it's like how to deploy .NET on Azure or something, right? Like right. We're not going to read that book. It's probably a great book, but it's not, it's going to be outdated in, 2 years. And, so we're kind of looking for these more evergreen sort of, type content.
And that's certainly what I encourage people to read. Evergreen material, whether it be on a website or in a book. It's the things that are the core principles that will carry you through all sorts of different technologies. Those are the things that I think really matter. Certainly that's been a very good thing for me to do in my career.
Yeah, and it's funny, and this is something we've picked up with other authors, is obviously when you're working with a publisher, there's the demands of the publisher, and there's not nearly as much freedom as just, I'm just going to put it on my blog and it can be whatever I want. And so for any author who says, I'm not going to write a book anymore because that's such a hassle and instead I can put it on my blog, like, I totally get it. We just have the good fortune of consuming it after, the sausage is made.
Right.
So, we have, and certainly if someone were to come to me and say, Carter, I'm going to read this book. I'm going to read this, 40-page essay on Martin Fowler's website. What should I do? I say, you got to read a book. Are you kidding me? You can't read, I think more what we're trying to encourage people to do is it was one of the big motivators for making this podcast is we noticed that there, at least in the podcast market, there was a gap for consistent, substantive, technical discussion. There's a lot of let's talk about the latest controversy of the week programming podcasts, right? And there's even a lot of like interview other programmer podcasts. But there aren't a ton of podcasts where people say, okay, let's just spend the whole time talking about refactoring. Let's spend the whole time talking about pair programming. And that's also really hard to do if you don't have a good base of material to be drawing from. And so we've actually been really happy as we've done this podcast that we always write up our notes beforehand of kind of all the things we want to hit. We never hit everything that we want to talk about. And so we hope that our audience finds it nice and substantive. And I think that's more what we were aiming for with the books is just, how can we create content that goes deeper than the surface level? And for us, reading books has been a great way to do that. But I also, you say like most people abandon after 50 pages, and like lots of the books we've read, I would have been in the exact same boat, but I have to keep reading because we record every Wednesday, right? So, and I don't think that's, I just think it's the nature of technical reading. It's hard. It's challenging, right? So we hope we encourage more programmers to read more, whether or not, and again, it's not so much you have to read these books for reading. If someone was listening to this podcast and is inspired to go read every blog or blog article on martinfowler.com, we'd consider that a huge success. I think it's more like get out of Twitter, get out of YouTube Shorts, get out of the 10-minute reaction videos on YouTube, right? Engage with ideas at a more substantive level. And that's what we're hoping people do when they listen.
Yeah, and books do encourage that. But I think there are good places on the web. I try to be one of them. I think I'm not the only one that also tries to do that. And one of the things I would say is look for those that are on topics that you think are still going to matter in 5 years' time, and look for articles that are long, because if they're long and they're well structured, that actually has a sign that there's something to them. And so I don't think, there are articles on my site or Jason Yip's thing on stand-up meetings where I don't think I've read anything as good anywhere else. Jason's article still, and it's ages old, and he's revised it a couple of times, because the great thing, again, with the web is you can revise it. And those kinds of pieces of content are real treasures, I think. And we want to highlight them wherever we find them.
Well, we'll have to circle back with you in email and see if there's anything you would recommend off the top of your head for that, because we have talked about, in particular, I'm wrapping up my master's degree next semester and taking one of the most difficult classes in the program. And so we've discussed like maybe 1 week we won't cover a book, but instead we'll cover a notable essay, right? Just to bring the reading load down a bit. So we'd love to get your opinion on some of what you think are the best essays or blog posts to cover, because we've discussed that as doing that on the podcast. Well, Martin, we thank you so much for coming on. It really has been such a pleasure having you. We always like to ask our authors before they leave, is there anything you've been reading lately, or anything just that you would really recommend to our readers?
Yeah, there's 2 books that I put to one side, knowing that having listened to your podcast, I know this question's coming. And they're 2 very different ones. So the first one is a strong recommendation for your podcast and for anybody who's interested in the stuff that you talk about. The book's called The Art of Agile Development by James Shaw. It is, for me, if someone says, what's the book you would recommend to give you a whole picture of how software development ought to be done, that's the book I'm going to pick. James is very much centered in the extreme programming style. So he's really teaching extreme programming. He pulls all the different pieces together really well. And it's also very practical. I really do feel you can read it and say, yeah, I could do these things. This is stuff that I can. My test when I'm working with authors who are on my website is, can the reader go and take this and apply it to work on Monday? And that's his book absolutely is suffused with that. There's a lot of philosophy floated around in books when people kind of feel the need to pad. James didn't go down that route at all. It's very much practical stuff and hugely sensible stuff as well. It is the best book, I think, on the software process, on software engineering at the moment. So I strongly recommend it to you and your authors, so you and your listeners to go for. So that's my down the middle software development book to pick that you need to show. The other one is what would be probably a more wacky one. So when I'm not writing stuff for my website or programming for my website or playing board games, which is my other big hobby, one of the main things I do is read books. I've always been a voracious book reader. I don't watch TV much. I'd much rather curl up with a book than watch TV. And the books I tend to read are history books because I find history just endlessly fascinating. And this book has also an interesting tie-in with software development. The title of the book is Make No Law, and it's about the Sullivan case. You probably don't know what that is because most people don't. So the Sullivan case was a legal case in the US in the early 1960s. Basically, a government official in Alabama sued the New York Times because they'd carried an advert that could be construed as critical to him. And he sued them for defamation. And surprise, surprise, the courts in Alabama found in his favor. But it bubbled up to the Supreme Court, and it became a very central case about First Amendment and freedom of speech. And the book talks about the whole background of this. It talks about the background of First Amendment, freedom of speech law, how this case came up, the nature of the case, how it was resolved by the Supreme Court at the time, because this is the Warren court, the sort of famously liberal court of the 60s, and Judge Brennan, who was the person who wrote the piece. So it's an important piece of history because lots of things we take for granted of freedom of speech are actually based on that judgment. You'll often hear it referred to, Sullivan, as being part of the tests. When people have talked about defamation and suing people, for a lot of it comes down to, does this pass the Sullivan test? But its tie into software development is when people ask me what non-software development thing is software development like, what people usually answer is they'll think about engineering, hence the civil engineering stuff that dominated in the 90s. My answer is legal work. Not the fighting of cases that we think about from TV shows, but the people who write the laws, whether it's legislators, whether it's judges resolving cases and effectively writing law in the process, or more commonly, whether it's lawyers writing the contract for some commercial agreement that we come across all the time. Because what are you doing when you're writing these agreements? You're trying to say, this is the way the actors in this system should behave. Now, their actors are humans and they're non-deterministic and all the rest of it, and we're writing for deterministic computers. But I think there's a great similarity. And a lot of the issues and problems, I mean, when you're writing constitutional law for the US, you are talking about one hell of a complicated legacy system that you've got to work around, right? And of course, the other thing to bear in mind is with the rise of things like Gen AI, maybe we've got to start being a bit more aware of how you write programs in non-deterministic actors. So, I mean, I think it's a fascinating piece of history, but it's also interesting parallels to think about as to think of it from as a programming problem of settling that case and the law that came from it.
That's fascinating. I had never made that connection. And I'm disappointed with myself for not recognizing the Sullivan case because I did constitutional speech and debate in high school. But it's, I'll have to give that a look because I am a big fan of constitutional law and I'm a big history buff too, especially like 20th century American history. So yeah, that's a great recommendation. We'll have to check that one out. Well, thank you so much for stopping by, Martin. We really, really appreciate you coming on.
And I enjoyed it, and I enjoyed listening to your episodes on the podcast. And I know you have at least one guest that I'm going to be looking forward to hearing from. Keep up the good work. Good podcasts are always fun to have. Fortunately, I don't have enough time to listen to all of them.
We have been pleased at the amount of people who will comment on Twitter or Reddit and say, like, most podcasts are dumb, but you guys made a good one. Like, hey. It's a very disposable
medium. We just have to get over that little bar. Yeah,
I know, right? Well, you can find us on Book Overflow on YouTube at Book Overflow Pod. We're on Twitter or X or whatever you want to call it at Book Overflow Pod as well. I'm at Carter Morgan on Twitter. You can find all of Nathan's newsletter links for Functionally Imperative at www.functionallyimperative.com. Martin, do you want to plug any of your socials, or you keep a low profile?
No, I certainly don't keep a low profile. Now, martinfowler.com is my website. I have an RSS feed there for all the material that I post on there. I am posting on Twitter, on Mastodon, and on LinkedIn, but it's mainly just announcing articles that come out. I'm not someone who sort of talks about what I have for breakfast or that kind of thing.
Well, fantastic. And the book, as we've talked about this whole podcast, it is Refactoring by Martin Fowler. We'll include a link in the description, along with links to the other books we've mentioned in this podcast. But thank you so much for stopping by, Martin. And thank you, listeners, for tuning in. We'll see you around.
Thanks for having me. Bye-bye.